When we start transforming the functions, we're going to transform the x and y parts separately, okay? Because the x's are coming from the input side and the y's are on the output side of the function, and they don't interact with each other. So we don't do the functions, the x and y transformations together. So once we have defined the functions and reference points, okay, this is our function, and the table represents the reference points. All the transformations actually work in the same way. It doesn't matter if it's a square root function, a quadratic, doesn't really matter. The transformations are going to work the same way, regardless of the type of function it is. Once we establish the function, the input and output of the function, we don't change this. This is now fixed. Okay, we don't change the inputs and outputs, and we don't use a function to calculate any transformation points. Okay, we don't use this square root or squared to change these transformation points. We're only going to use the x transformations on the x and the y transformations on the y. Okay, so when we define the function, okay, so we happen to have a semicircle function. The semicircle function has these three distinct points to help us define the function. There's a point here, here, and here. Okay? Those are our reference points, and those are the points that we're going to keep track of when we transform them. And again, we are no longer going to use this function to calculate coordinates. We're just going to apply the transformations now, because the function is now defined. So when we do the transformations, we'll start with the y. Okay, so the change in y, okay, the change in y function, the y values, is going to be based on anything on the outside. Inside is x, outside is y. And when I look at the transformation, it's going to be plus 2 on the outside. When I write it, you apply the function notation. Notice that the square root represents the function. The plus 2 is on the outside. And those are all my y transformations. So I'm just going to focus on the y. So my new y is equal to my old y plus 2. Okay, the nice thing about the y's is it's pretty straightforward. What I see when I see plus 2, that's what's going to happen. So I take all these y coordinates and I'm going to put it through that transformation. I get these new y coordinates. Okay, so my new y coordinates are going to be plus 0 plus 2, 3 plus 2, 0 plus 2. So those represent the transformations on the y. Once I've done that completely separately from the x's. Now I go to the x's, and I do the x's independent of what I did for the y's. And that minus 3 represents the opposite of what I'm going to do. So basically, I need to get back to this minus 3 here. Okay, so what x minus 3 is going to get me back to the negative 3? And that's why it's backwards, because we're actually going the other way around. This is going to be the x that I want here, and I'm going to do some calculation to get back so I can plug it into my function. So when I do my x's, my change in x's, I'm going to do it in this way. I'm just going to take my old x, okay, so this is my x minus 3, and I'm just going to actually I need to get back to this old x here. So this is actually my new x. And the reason why it's backwards is because really I'm just kind of undoing this minus 3. So I'm going to then take this expression and use this as my calculation. It's going to be plus 3. Okay, so I'm going to just solve for this x here, doing plus 3 on both sides. And now I'm going to use this expression to calculate my new coordinates. So I need 0, 3, and 6. So basically this minus 3 is moving it to the right 3. Okay, so that's the kind of first layer of understanding. Why is it going backwards? It's going backwards because really what's happening is I need to take this x, subtract 3 to be able to use it in this table. Okay, so it's actually going backwards in my function. I'm actually not going from my old to new in the function notation. I'm going from new to old. Okay, so instead of doing that, I do I want to undo it, and I just rewrite it backwards. So instead of minus, you use its inverse or opposite, plus 3. And then I can go from my original table to my new table. You can see that these coordinates now then match. 0, 2, 3, 5, 6, 2 are those same three coordinates that have been transformed. And again, I transform these coordinates all independent from each other.